excuse me, let's think back to inverse functions real fast. Does anyone remember if f is a function, how do you write its inverse? F to the... Let's remind ourselves something about functions. If my function has the point, let's say 4, 5. Does anyone remember what the inverse would have the point? 5, 4. Okay, Elliot Lang, 5, 4. Go past that candy jar. Okay, if a function had the point 2, 0, what's the inverse point? Every time. Okay. Does it have to be f and f to the negative 1? No, they might say, hey, we've got two functions and f and g are inverses. So if f has the points 7, 6, what does g have the point? 6. Cube root, exactly. Whoa. With that being said, let's go remind ourselves what today is. You know how this whole derivatives thing, we're talking slope. Slope is just the whole first semester of our class, basically. So they're curious, what's the slope of inverse functions? Okay, so first thing I wanted y'all to do. If the function has these 1, 2, 3, 4, 5, 6 points, give me its inverse. We're going to call the inverse g. If the function has the point -3, -26, what does its inverse have the point of? You know it, Mr. Paletta. All right, you guys, good work. We got, what about -2, -7? What's the inverse of that point going to be? You know it, -1, 0? You got it. We don't even have to say those out loud. Go ahead and finish off that chart. And I am going to amend our notes a little bit, okay? Notice things that I've crossed out, but we aren't there yet. What if I ask over here, what's the slope when x is 1 of my f function? They want us to just estimate. We can do that. Estimate the slope when x is 1. What minus what over what minus what? Okay, Campbell, I love it. What's my slope going to be? 8 over 2, which is 4. Beautiful. You guys, beneath it then, it says, well, okay, estimate the slope of the inverse, g, when x is 5. And you're like, okay. Well, when x is 5, do you agree that that still falls kind of between these two? 5 is between 1 and 9 is the middle of it. Great. Let's do the slope there. 2 minus 0 over 9 minus 1? What's that going to get me? 1/4. What do we notice about this beautiful 4 and that beautiful 1/4? They are just reciprocal. Reciprocal is the word we would use with when a number is flipped.
But like they are inverse.
No. The points are inverse points. So, okay, maybe let's put this together, guys. Ready? When functions are inverses, when the functions are inverses, their slopes are reciprocals. Together, we got it. Okay, G? So, here's what things that I want you to cross out. Okay? So, we're going to skip the doo-dah. Very good. We're going down here. I want you to go ahead and write, all right, our function is going to be x cubed. Function is x cubed. Let's go plot some points. And you guys, I'm going to start with our x's. I'm going to tell you what I want those x's to be. -2, -1, 0, 1, and 2. If my function is x cubed, what's -2 cubed? -8. -1 times -1 times -1. 0 times 0 times 0. 1 times 1 times 1. 2 times 2 times 2. Beautiful. The inverse. Let's go flip those points. If the function had the point -2, -8, what does the inverse have? Okay. -1, -1 turns into -1, -1. 0, 0. 1, 1. So many same points. 8, 2. Okay, great. You guys, we're going to go plot both of those. So I'm going to go in red. I'm going to go -2, -8. 2, 4, 6, 8. Okay. -1, -1, 0, 0, 1, 1, 2, 8. Does that look like a cubed graph that we're used to seeing? Yeah. Then when I go to plot its inverse, -8, -2, lots of points overlapping, and that's fine. We go like this. Anyone remember what this purple graph, what the inverse of x cubed is? Yeah, does anyone know that with that function? So this is x cubed. How would I write the equation of the other one? The cube root of x is the inverse. Yeah, that's cube root graph. Very good. Not that we have to know that. Okay. And then, do you agree that these are inverses? So their slopes should be reciprocals. So I went ahead and I crossed this stuff out here. And I'm just curious, you guys don't even have to write this out if you don't want. But what's the average rate of change from -2 to 2? I'm just curious of my original function. From -2 to 2, my average rate of change would just be this straight line. And I'm going to try to give myself a straight line. Boop. Okay, that's going to be my average rate of change, which is just the slope. What's the slope of between those two big points? Say that again? How'd you get that? Up 16 and over 4 is just going to get me a slope of 4. So, Mr. GM then, what would you say the slope of my purple line is going to be now? Wouldn't it just be the reciprocal? And it is, because we're going to go up 4 over 16. So those slopes are always going to be reciprocals. Okay? Just something to throw out there. And you guys, we're going to cross out the first table. Very good. Thank you, GF. Here we go, people. Here we go. I'm going to say, oh, too funny. Okay. When they give us this minimal info, let's look at what they're saying. Hey, a function has the point 2, 8. I'm going to go ahead and make myself a little chart. Oops, my function has the point 2, 8. 2, 8. What would the inverse have the point of? 8, 2, right? And look what they want. They want the inverse's derivative when x is 8. They want, and this is kind of funky to write, the inverse's derivative. Look at how I just did that. This is kind of, Gavin, how you said f to the I. It almost looks like that with all these crazy exponents that I got. F to the -1, derivative. Wait, so this is, no, that's a good question. That's a great question. This is letting us know that we're dealing with an inverse. This is letting us know that we're dealing with the derivative.
See, that's when you need to draw the full one. So that's to differentiate them.
Yeah, that's an apostrophe. Yeah, it's an apostrophe. Good call. Yeah. That's a great question. And they want that at 8. So I just rewrote this up here. Yeah, but it is weird to say. So that's why you're often going to see them say, hey, G is the inverse. This is annoying to write inverse and then derivatives with it. They often rewrite it as another variable. Okay, you guys, do you agree this guy's slope is going to be the reciprocal of this guy's slope? But this guy's, the inverse's slope at 8 is going to be the reciprocal of the function slope at what x? 2. That's where it gets a little funky. Let me say this one more time. Because they both have the point 2, 8, and then 8, 2, the slope of the inverse at 8 is going to be the reciprocal of the slope of the function at 2. Okay? Could we go get f prime of 2 if we know what f is? We can do that. Let's go find f prime of x first. What's f prime of x? 3x squared. So can we go get f prime of 2? Say it again? 12. So if f prime of 2 is 12, because 2 squared is 4 times 3 is 12, what would its inverse's slope be when x is 8? 1/12. That's my answer. So on this next one, it says f, they gave us some points. The graph of f has the points 5, 20, and it has the point 7, 5. I'm going to skip this info for right now. They tell us G is the inverse. So I'm going to make another little chart that says G. If my function has the point 520, what does my inverse have the point? 25. If my function has the point 75, what does my inverse have the point? Beautiful. They did give us, okay. So they want to know what is G prime of 5. They want to know the inverse's slope when x is 5. Do you agree 5, 7 is the inverse point of 7, 5? So I need to go find this guy's slope, not f prime of 5, even though that 5 would match this 5. They did that on purpose. We need to find f prime of 7 and take the reciprocal of that. since 7, 5 is the inverse point of 5, 7? Did they give us what f prime of 7 is? Perfect. If f prime of 7 is negative 5 halves, what would g prime of 5 be? Good. We keep the negatives, you guys. Perpendicular slopes are opposite reciprocals. Inverse slopes are just reciprocals. Keep the negative if it's there. Let's see. We're going to skip 5. We're going to come back to 5 the last. We're going to do 6, then 7, then 5. Here we go. Let's do 6. Don't mind me. They said f has the points negative 5, 7. G, it says G is its inverse. G then has the point what? 7, negative 5. Kevin? They want f prime at negative 5. Well, how am I going to find that? What's that going to be the reciprocal of? G prime at what x value? 7. Do we know what G prime of 7 is? They gave it to us up there. G prime of 7 is 3, so what is what they want? F prime of negative 5? 1/3. Guys, this is as hard as it's going to get. We got this. We got this. Light work, I agree. Let's try 7. Them telling us that it's an increasing function, we don't care. We have the point. I'm going to make a little chart. F has the point 10, 5. F prime of 10 is 8. It says, which of the following statements about the inverse of f must be true? You want to know what helps me? I'm going to go write inverse, and I'm just going to go write my new points. With that, they didn't ask me to, but I think that really helps me in these situations. If the function of the point 10, 5, what's the inverse? 5, 10. So then what's the slope of the inverse? Again, how I say that is f prime derivative. Ugh, because that's what they asked for right here. Look at that. The inverse's derivative. The inverse's derivative. At what x value? What's my x of my inverse?
5.
5. Do we know what that is? Oh, yeah. If we know the function has the slope of 8 at that point that corresponds to each other, the inverse would have the slope of, not ideal. I cut off the 1/8 with the hole puncher.
You just messed something up.
So it's D, but y'all wouldn't have known that. That's my fault. Last one, number 5, and then the time is yours. On number 5, it says the function is given. I haven't given you the function before. And then I gave you a point. H of 1 is 2. I love myself a chart. You guys have taught this a lot of different ways. This chart, in my opinion, has just been the best for the kiddos. So you're saying H has the point 1, 2. What would the inverse have the point of? 2, 1. They didn't ask us to write that. I just think it really helps on the next step. Because they want the inverse's derivative at 2. Well, I don't know what the inverse of this is. But could I go find H prime of what? At 1, right? And take its reciprocal. Let's go find H prime of x first. To Campbell's point, we got to do it with respect to x first. H prime of x. If h was x to the 5th plus 3x minus 2, h prime? Yes, ma'am. 5x to the 4th plus 3. The only point we have is 1, 2, which is then translates to 2, 1. So we're going to go plug in a 1 to my x. We're going to say, all right, h prime of 1 would be 5 times 1 to the 4th plus 3. I heard 8. So my h prime of 1 is 8. Therefore, my inverse's slope when x is 2 would be 1/8.